So click on file, click on new model. Now let us select use settings from model file. I've shown you in the introduction video how to use the second option, so the link is also in the description. So click on OK. So select intro, click open. Now let us keep the grid lines as it is, like number of grid lines as 4, in y direction also 4. Now let us keep the spacing in x and y direction as 4 meters. And let us keep the number of stories as 4, to g plus 3 story, and the bottom story height, that is from the bottom story to the plinth level or to the foundation, the height would be 4.5 meters. So click on OK. Now we can see here that 4 grid lines in x and 4 in y have been formed with a spacing of 4 meters and the bottom story height. So here I can show you by using these arrows. So you can see that the story 1 height is 4.5 meters and the rest are 7.5, that is 3 meters each. So let's assign the properties of the beam first. So select quick draw beams and select the property, that is, let us give a property of B 300 by 300. Now I have also mentioned in that introduction video how to define these properties and the section properties. Let us provide the beams. You can add the beams by simply moving the arrows. Now here you can see that we have mentioned one story. If we would have mentioned all stories, and let us go back and draw the beams, then you can see that the beams would be formed in all the stories. Here when you draw beams and columns, you need to keep it as all stories, and if you draw for slabs, then you need to use similar stories. So the beams have been drawn, and now let us draw columns. So select quick draw columns, select the property, that is C 300 by 300. Now here you can't select B 300 by 300 because I have shown this in the introduction video. So do watch the introduction tutorial. Now if you drag it, you can see that the columns have been formed. For drawing of slabs, let's select similar stories, and here you have draw floors. So select this command, and the reason why we are using similar stories is because when we draw with similar stories, you can see that the slab has not been formed at the foundation level. Now when you use all stories, and if I draw here, you can see that slab has been also formed in the foundation level, which is not required. So undo the command and select similar stories and assign the slab. So here you have given the beam properties, the column properties and the slab properties. Now after this you need to assign the restraints to the joints. To select the restraints, use the normal cursor, go to plan, go to the base, click apply. Here you can see that these are the base level column points. So select all the points. You can see all the points have been selected. Click on assign, click on joints, click on restraints. Now select here the fixed, click apply, click OK. So now let us apply the loads. In E-tabs you need not provide self weight because the self weight will be automatically taken, unlike in Stat Pro. So here you need to provide the live loads and the additional dead loads acting on the structure. Here you need to select the slabs of all the levels. Click here select, object type, click on floors, click on select. Here you can see all the floors have been selected. Click on assign, click on shell loads. Now if you apply the load on the beam, you need to select frame loads. If you apply it on slab, you need to select shell loads. Uniform. So let's give a loading value of 1.5 kilonewton per meter square. Click on replace existing loads, click on apply, click OK. Here you can see that the load has been applied. Now let us apply a live load on the same slab. So here you need not again go into the select option. You can use this previous selection button. So just click on the previous selection. You can see that all the slabs have been selected. So click on assign, click on shell loads, click on uniform. Now here select live. Now for a residential building, the live load is 2 kilonewton per meter square. So click apply, click OK. Now here you also need to assign the wall loads acting on the structure. For exterior walls, the wall load will be 12 kilonewton per meter square, and for the interior walls, the wall load will be 6 kilonewton per meter square. So here select all the exterior beams. Here you can see that all the beams of different stories have been selected. This is because we have chosen similar stories. So likewise select all the beams. Now be careful in selecting beam. If you press in the center, the slab gets selected. Now here you can see that all the exterior beams have been selected. Now click on assign, click on frame loads, click on distributed load. So let us give a load of 12 kilonewton per meter square, that is dead load. Click on apply, click on OK. Here you can see that on the beams 12 kilonewton per meter square load has been applied. Now select the interior beams. Click on assign, click on frame loads, distributed. Now let us give a value of 6 kilonewton per meter. Click on apply, click on OK. Here you can see that 6 kilonewton per meter load has been assigned. Now if you want to remove this loading values, you can use these two commands. Now this command is for the frame loads, that is load applied on the beams. So click on frame loads, click on unclick the show loading values, click apply, click OK. Here you can see the loading values have been gone. Now similarly, if you want to check the values that are acting on the slab, so use this symbol and click on apply. Here you can see that dead load which we have given has been showing. Now if you change this value to live, you can also see the live load that is acting on the structure. Click on close. So if you want to remove the values, so just simply click on the undeformed shape. Here if you want to see the extruded view, so click on 3D view, click on extruded view. Here now let's come back from the extruded view, or simply close this, and now let us analyze the structure. So before analyzing, you need to give the load combination. So click on define, click on load combination, add new combo. So click on dead factor is 1.5. Here click add and select live, and the factor is 1.5. Let's name it as, let's give 1.5 dead load plus live load. Click OK, click OK. So before analyzing, we need to check whether the model has any errors or not. Click on analyze, click on check model. So click on select deselect all, OK. Here you can see a message has been given, model has been checked, and no warning messages were generated. So close this. Now here you need to analyze the structure. Click analyze, click run analysis, save it as sample model. Here you can see that this is the deformed shape of this model. Now if you want to view the bending moment diagrams and the shear force diagrams, so click on this figure and choose moment 33 and click on show values, click on apply. Here you can see the bending moment diagram. If you are confused in seeing this diagram, you can also see the diagram with the help of the elevations. So click on elevation, select elevation 1, click apply. OK. Now this is the bending moment diagram of elevation 1. Similarly, you can view the bending moment diagram of all the elevations, and you can also do a manual design if you want. And let's go back to the undeformed shape and 3D view. Now if you want to see the stress diagram of the slabs, click this symbol. Now select M22, that is the moment, click apply. OK. the stress level is higher at the center columns. So if you provide a greater section at this point, you can reduce this. Similarly, you can also view the maximum bending moment, and you can also check the values. Click on apply. OK. Here this is the maximum bending moment values of the slab. So if you have any confusion, just go to plan. So select story 4, click apply. OK. Here you can see that the maximum bending moment near the column is 15.4 and it reduces as it moves further. So this is how you check the stress levels in the slab in ETABS. Now in ETABS you can't design the slab, but from the values of the bending moment you can calculate the steel by manual method, whereas design of beams and columns is done in ETABS.